Hello everyone, I'm Sonico Yalo and today we are going to introduce the chapter 5. This one is called Solutions and Aqueous Reactions. There is something called gastronomy, sorry, molecular gastronomy. This one is a way of making food by, um, it's a way of making food by using chemical reactions. But we are not going to talk about the food part. We're going to talk about the reaction point. So there is something to happens a lot in this kind of gastronomy, and it is the precipitation reaction, and it is divided by two. The homogeneous mixture that is a liquid with a solid inside of it dissolved, and then the other one that is a mixture that is only two solids but mixed together. I'm not sure if it's melted or way of mixed in, but solid. So there is something similar that chefs uses, uh, and is similar to this kind of precipitations. That is called the espherification. I took a long time learning that. Espherification. This one is taking care of, or better say, is a way of, how is this word? Encapsulate. Encapsulate a liquid or liquids. For more explanation, is like a gel. This gel goes around the liquid and encapsulate the liquids inside. And in the middle, it makes like a sphere. I'm not sure how that can be, but um, that's the explanation. So now we can go with my partners that are going to explain more and disclose more this topic.
Hi, my name is Nathaniel Basintaban, and today I'll be covering solution concentration and molarity. Now, we began with talking about certain homogeneous mixtures, ones with uniform composition, such as salt and water. Now, homogeneous mixtures are also called solutions. The majority component is solvent, minority component solute. A solution where water is used as a solvent is the aqueous solution. Now, there are certain types of concentrations which come up in certain solutions. Dilute, they have a smaller amount of solute, and concentrated have a larger amount of solute. Since they are mixtures, the composition of these solutions can vary. And we quantify these with the amount of solute relative to solvent. Now, to express concentration, we use molarity, the amount of solute in moles against the volume of solution in liters. And these are examples of different types of preparing of solutions. Now, for this problem, how many moles of solute are required to make 3 liters of a 2-mole solution? Now, in order to do this, you simply need to set up the equation and multiply.
Hi everyone, my name is Valeria Hilsa. I'm going to talk about what I learned from chapter 5, and my topic is precipitate reactions, which occurs when two aqueous solutions are mixed and produce an insoluble solid called precipitate. This happens when the cation from one dissolving ionic compound pairs with the ionic from the other, forming a new combination that doesn't dissolve in water. To predict whatever precipitate will form, I need first to identify the ions in each reactant. Swap the cations and onions to figure out the possible new products and check the solubility using the solubility rule. For example, compounds with sodium, potassium, and ammonium ions are always soluble, while most compounds with hydroxide and carbonate ions are insoluble unless paired with certain exceptions. If neither possible product is solved, there's not going to be a reaction. I also learned to represent these reactions in 3 ways. A molecular equation, a complete ionic equation showing all dissolved ions, and a net ionic equation, which removes the spectral ions that don't actually participate in forming the precipitate. For example, when lead nitrate reacts with potassium iode to form the classic yellow lead iode precipitate.
Hi, Dr. Sharma. This is my chapter 5. I'm still working on chapter 5, so I haven't really been able to say what is difficult for me just yet. But for this chapter, I decided to review what we just did in class earlier today. So that is going to be participation reactions. That is a solids form when we mix 2 solutions. Aqueous solutions of ionic compounds produce an ionic compound. Oh my god. That is insoluble in water. The insoluble product is called participate. So no participation means no reaction. Participation is kind of when, I think it says right there, when you create a solid. Actually, maybe this is actually a topic of difficult for me because I'm still trying to understand how to predict it. So I haven't worked on how to figure it out, but I am going to list off what are the rules here. So to predict participation reactions, first thing you want to do is determine what ions constitute with each aqueous reaction. Second of all, you want to determine the formulas of possible reactants. So you'll exchange ions. So positive ion from one reactant with a negative ion from other. Balance charges of combined ions to get the formula of each product. And then 3, you'll determine solubility of each product in water. Determine the solubility rules. So this is going to be a toughie for me because this is something I have to remember. If the product is insoluble or slightly soluble, it will precipitate. Not participate. If neither product will precipitate, write no reaction after the arrow. This is we did a lab on this. And 5, if any of the possible products are insoluble, write their formulas as the product of the reaction using S after the formula to indicate solid. Write any soluble products with a Q after the formula to indicate aqueous. Balance the equation. Remember to change only coefficients, not subscripts. In class. All right, and that is actually all for me. So thank you. That was my chapter 5, which I'm still reviewing at this time. So if that was a little less detailed, I'm still working on it. Thank you.
So one thing I learned in chapter 5 was oxidation and reduction reactions. So oxidation and reduction, they're always going to happen together because one atom loses electrons while another has to gain that electron. I also learned that oxidation means to lose electron and reduction means to gain the electron. So the reducing agent, it loses electrons and is oxidized, while the oxidizing agents gain electrons and they are reduced. So, I would say that might have been the only tricky part of this topic, was just to remember the difference between the two. That's pretty much it. I mean, I overcame that obstacle by doing practice problems over and over, doing the ALEKS, and I just had to remember that the reducing agent loses electrons and the oxidizing agent gains the electrons. And once I remembered that, it was fun.